Saxon's Trig, Lesson 98, Change of Base and Contrived Logarithm Problems. So we've talked before about the fact that the word log has a base of 10 and natural log has the base of e. So what they're going to do in example 1 is ask you to find log base 5 of 15. So if we rearrange that, you're basically asking yourself 5. There is no equal, so to an unknown exponent to get to 15. Now, these are two different bases. Can I force them to have the same base? Well, not without logging them. So if I did a log on both sides to solve for y, I would be pulling it down out of the exponent and multiplying it with log 5 equaling log 15. And then to solve for y, you would divide by log 5. And then on the calculator, log 15 divided by log 5 is going to give you a decimal answer of 1.68. Now, I would like a shortcut to do that. And so rather than having to do the algebra every time, which would work the same every time, what I've memorized is that if I just take the log of the large number here, not because 15 is bigger than 5, I'm saying in this spot, whatever the number is in this spot is the numerator. So log of it divided by log of the base, you will always jump straight to what you need. So if I do that in example 2, I will do on my calculator log of 82 divided by log of, and the base was 7, and then just calculator, and you'll get 2.26 for that answer. I guess I could box that one. And it doesn't matter whether it's y equals, because, you know, I created that y myself. It could be x equals or whatever. Typically, I would just have that. Okay. The other thing that they kind of point out here is there can be a bit of wiggle room between the answer that you're getting, because you're saying 7 to the power of 2.26, and depending on where you round it, might get you like 81.9 or 83.007, but it should be in the ballpark, but it won't be accurate because you're rounding off that decimal. Now, in part B, the contrived log problems, you are, well, I'll remind you of these facts. Anything to the 0 is 1, and log base b of 1 equals 0 is the other way to write that. And then if you have a log statement in a denominator, you know that you can't have negatives with log statements, so your answer has to be something that is greater than 4. Yeah, that's all I'm going to remind you about on those. So let me look at example 3. Solve log x squared equals log x. Now this whole thing is squared. So I don't know why they call it contrived. They're not really making them up per se. You can encounter something like this, but I guess their idea is you have to manipulate things in order to solve. So this 2 is actually multiplying in front because it is the exponent of a log base x equals, and then you obviously have log x multiplying with log x because that's what the squared actually means. Now, I have two options at this point. I can assume that I can cancel off a log x both sides, but if I do, I'm eliminating an answer. So I try to avoid, just like we learned in a previous lesson, not to divide something out, but factoring is always better. So that being the case, I'm going to set the problem equal to 0 and move this over and make it to minus 2 log of x. Then I'm factoring out a log of x from both of those statements. So this one still has the extra log of x. This one has the minus 2, and we're going to solve each of those. So this first one, log of x equals 0, and in this one, log of x equals 2 if I move it over. So x to the 0 power is what I have here, and that equals 1. And this is x squared Oh, wait, just 1 second. No. It didn't matter on this one because anything to 0 is 1. The base is 10. 10 to the 0 is 1. The base here is 10. 10 squared equals the x. So that would be equals 100. So my two answers are 1 and 100. And I should throw them back in to make sure I don't get negatives. 1 and 100 doesn't make a negative here or here. So we're good with these being our two answers. Now, example 4. Says solve log of radical x equals the square root of log of x. So these are super similar, it's just they're changing where the radical is, and in example 3 they change where the squared was. All right, so the first thing I see here is that this x needs to be changed from a square root over to its fraction format. So the exponent is a 1, that's the numerator. The denominator is whatever the root number is, that implies a 2 for square root, equals, and then let's do the same thing here. Log of x is now being written to the 1/2. And we can move this half to the front because it was the exponent for log of x equals, and no change here to any of this. Again, I want to solve for a log of x to the first power, not to the second power. And I know I want to factor, so I should get it equal to 0. I don't want to do this out of order and confuse you. I'm going to fix this exponent first to get this to say log to the x to the first power, which is better than having it to a fractional power. So what can I do to 1/2 to turn it into a 1? Well, that's multiply it by a 2. And if I do that to this side so that this has now become log of x, I need to do the same thing and make sure that I am squaring every part of this side. So a 1/2 squares to a 1/4, and then this is log squared x. And like I did in the last example, I should write that as log x, log x. I just didn't exactly have a great deal of space. So I'm going to fix that as I move things to the same side. So we're going to do 1/4 log x times the other log x minus this one as I move it, log x equals 0. Then pull the log x out. So this one is keeping a 1/4 log x minus, and if I pull the log x out, I need a placeholder of 1, and it equals 0. So now this one will be set equal to 0, and 1/4 log x minus 1 will be set equal to 0. So when I rearrange, 10 to the 0 is the x, so x is 1. And here, I gotta fix this first. So log x, move the 1 over, making it positive, over 1. I'm just gonna make that a fraction because I wanna get rid of this fraction, which is divide, so I'm gonna flip and multiply. So times 4 over 1. So this is actually log x equals 4. So 10 to the 4th is my x, and x then would be 10 times 10 times 10 times 10. I think that's right. Yes, at 10,000. Yes, okay. Because it should be, the exponent should match the amount of zeros. So my two answers are these, double checking that I don't have any negatives when I plug into the square roots, and we're good. Okay, example 5. Log of log x equals 3. So the first thing I would do is rearrange this to see what it gives me. So the implied base of 10, exponent of 3, equals the log of x. Now this 10 cubed is actually 1,000, 3 zeros matching the exponent, equals log x. All right, so then I'm rearranging here. So this gives it a base of 10, an exponent of 1,000, and that equals the x. And then that is really huge. So I'm not actually going to do that, nor would I recommend that you do it on the calculator. I would just box this as the answer at that point. And then example 6 says to solve for x with the exponent square root of log x equals 10 to the 8th. So I would get rid of the exponent out here and put it as a multiply in front. Square root of log x of x equals 10 to the 8th. Then I would remove this 10 by logging both sides, so that when I do that, I have an 8 multiplying with a log 10. But when I do that, log 10 cancels out the log with the 10 and just leaves me equaling 8. Okay, so I'm going to leave that on that side. Now, to accomplish that, I logged both sides, which means that this stayed as the multiply part. What I logged was the x piece, and now debating if I want to change that over to the half. Yes, that's what I would do next. So this log of x in a square root can be written in its exponent form, which implies 1/2, multiplying with another log of x who has an implied exponent of 1, and if I give them a common denominator, that's 2/2. So that's going to give me log of x to the, and then when you multiply bases, you add exponents, so that's 3/2. And it still equals that 8. Now I want to turn this into a 1, just like I did before. So we're asking ourselves 3/2 times what gets me to a 1? Well, that's the flip of this. So 2/3. That's going to keep me log x on this side equals, and then this 8 gets that same 2/3. So this again implies cubed root of 8 and then the exponent of 2, or you can do 8 squared, 64, and take the cubed root of 64. I just like working with smaller numbers, so if I can, I will always do the root first. What number 3 times gives me 8? 2 squares to 4, and you would get the same thing if you did the cubed root of 64. Now you can rearrange the problem. 10 to the 4th power equals x, and I can handle 10 to the 4th power. So there is the answer.